So one of the things that we talked about in class was the idea that when you have numbers such as 7 and 5 and you multiply them to get 35, 7 and 5 are called factors and 35 is the product. We also talked about finding the prime factors of numbers in question. So for example, if I think of the number 34 and I think of the number 68, if we are asked to find the greatest common factor and we don't know off the top of our head how or what the number may be, we would list the prime factors of 34, which are 2 times 17, and of 68, which are 2 times 2 times 17, and then you would find the factors they have in common. They have a 2 times the 17, which means that the GCF of 34 and 68 is 34. With that, finding the greatest common factor of a polynomial is basically asking you to find what factors multiplied to give you a product. So we know that to multiply items such as these on the left, you distribute. And so when you're working backwards and you're given the product and asked for the two factors, you're going to divide. You're going to factor out the GCF. So when we have something such as 12mp plus 80m squared, your job is to find out what number did you multiply to the binomial so that when you multiplied the first one, it gave you 12mp, and when you multiplied the second one, it gave you a positive 80m squared. In order to do that, the first step is to factor out or divide the greatest common factor. So you look at the two terms, 12mp and 80m squared, and you list the prime factors. Remember, we use prime factors because it just makes it so that you don't make a mistake with factors. 12 is 4 times 3, and 4 is 2 times 2. So 12 is 2 times 2 times 3, times m times p. 80 is 8 times 10. 8, hopefully by now you remember, is 2 times itself 3 times. And 10 is 2 times 5. So written out the long way, it's basically this, and 10 is 2 times 5. So the prime numbers are 4 2's and a 5. And m squared is m times m. Now what do we have in common? What's the most greatest? What's the most that we have in common? We have a 2, which is also multiplied by another 2. We don't have anything else besides 2 and 2, but we have an m in common. So our GCF is 4m. Once you find the GCF, basically what you're asked to find is the remaining factors in the polynomial. So you know that the GCF is out in front. So basically it's GCF times something that happened in here, whether it's a binomial or a trinomial, depending on what you had. That's what you multiplied. So if I know that 4m is what I multiplied, when you're looking back at the original 12mp and 80m squared, you ask yourself, well, if I got 12mp when I multiplied 4m by something, then obviously I'm going to divide 12mp by 4m. So that means this must have been 3p, because when I multiply it, I get 12mp, okay? And then it's plus 80m squared. So 4 times what gave you 80? 20. And I have an m. What must I have here so that when I multiply this to this, I get 80m squared? And obviously there has to be another m so that when you multiply it gives you that. And always check your work by distributing again. So if we redistribute, we get 4m times 3p, which is 12mp. And then we get 4m times 20m, which is 80, positive 80m squared. So we know that it's correct because it gave us the same exact answer to begin with. So we're undistributing, basically. In this case, there are 3 terms. It's a trinomial. So the first thing I look to do is to find the GCF. So 8x to the 4 plus 4x to the third and negative 2x squared. What number goes into 8, 4, and 2? 2. If I have 4 x's, 3, and 2, the most we have in common are 2. So that's the GCF. From that, I go to the next step, which is, all right, if you know that the GCF is 2x squared, that means that you must have taken 2x squared So looking back at the original, 8x to the 4 plus 4x to the 3 minus 2x squared, I must have gotten the 2 and multiplied it by 4 to get 8. And if I multiplied to get 4 x's from x squared, this must have been x squared. Then 4x to the third divided by 2x to the 2 is 2, because 4 divided by 2, since 2 times the 2 gave you the 4. And if I ended up with 3 x's and I have 2 that I multiplied, there must have been 1 here. And then lastly, I have a 2x squared, and I multiplied it by something, and it gave me negative 2x squared. Well, negative 1 must have been the number, so that when I multiply that, I get negative 2x squared. So the factored form is 2x squared times 4x squared plus 2x minus 1. And we check our work by taking our factored form that we just did and redistributing it to make sure, and there was a 2x squared, make sure that we get the same answer. So 2x squared times 4x squared is 8x to the 4. So far it's the same. 2x squared times 2 is 4x squared. So I noticed that I forgot to write that extra x because it wasn't the same. So now it's going to be 4x to the third, and I had it correct here, I just forgot to write it. And then 2x squared times negative 1 is negative 2x squared. So I see that I got the same exact trinomial that I started with. So this is the factored form. Next one. Factor out the GCF. Well, looking at negative 14x and negative 12x, negative 14x is negative 2 times 7, or 7 times negative 2. And then we have to remember that a negative number, really, negative 1 is one of the factors. So in reality, this is negative 1 times 2 times 7 times x. And then negative 12x squared is negative 1 times 2 times 2, that's 4, times 3, which is 12, and then 2 x's. The GCF is negative 1 times 2 and an x. So that gives us negative 2x. If you didn't do it this way because you felt very comfortable with 14 and 12, knowing that 2 is the biggest factor of them, just remember that if there's a negative in front, you always factor out the negative. So if 2 is what goes into both of these, 2x, it's also negative 2x. Once I have that GCF, you take that GCF and you write it in terms of it. So negative 2x multiplied by, I have a binomial, which means I must have had a binomial to begin with. And then you ask yourself, negative 2x times what gave me negative 14x? And that is positive 7. Because negative 2 times 7 is negative 14x. Negative 2x times 7 is negative 14x. Similarly, I look at the negative 2x and the second term of negative 12x squared. Well, negative 12x squared and negative 2x, how did I get to negative 12x squared from negative 2? I must have multiplied by positive 6x, because negative 2x times 6x gave you negative 12x squared. At this point, based on the fact that we already finished the first lesson, which talks about standard form, you've got to make sure you know that in order to write properly, you have to write it in standard form. So the 7 plus 6x is really going to be 6x plus 7. Could you have organized it in standard form to begin with? Absolutely. You could have taken this and from the very beginning written negative 12x squared minus 14x and then looked for the GCF. Well, what factor goes into negative 12 and negative 14? Negative 2. What can I take out? If I have two x's here and one here, one of them is in common. What does that leave me with? Well, if I was given a negative 2x and I multiplied it by something and it became negative 12x squared, the first number must have been 6x. And same thing, if I was given a negative 2x and I multiplied it by a second number and it gave me negative 14x, well, this must have been positive, so that it multiplied to a negative 7, because negative 2x times 6x is negative 12x, and negative 2x times positive 7 is negative 14. And again, I made that mistake as I'm speaking. Negative 2x times 6x is negative 12x squared. So pay attention to those little things that we often make mistakes on. Quadratic, cubic trinomial. So what can I take out of all three of these? Well, when in doubt, write it out. 3x to the third is really 3, because it's a prime number, times x, 3 times. 2x squared is 2 times x twice. And negative 10 is really negative 1 times 2 times 5. We have a 2 in common with the 2x squared and the negative 10, but it's not also in the 3. Because we don't have them in all of them, the GCF is just 1. And if 1 is the only GCF, then it means that the example that you have given to you is already factored. You can't factor it any further. It's basically only going to be 1 times 3x to the third plus 2x squared minus 10. And there's no need for you to write that extra 1 on the outside. You would just write it as already factored. Okay, let's look at example 2. Mandy's calculator is powered by solar energy. The area of the solar panel, so I'm imagining in my head a rectangle, and the area is 7x squared plus x. Okay, so let's draw that picture a little bit bigger. Let's say this is the calculator, because this is the shape of a calculator. The area, so the length times the width, length times width, is equal to 7x squared plus x, centimeters squared. Factor the polynomial to find the possible expressions for the dimensions of the solar panel. It wants to know what are the lengths and the width. So you're factoring, which means you are doing what we just did. What can I factor? You always GCF first. Always GCF to factor first. That's the first step. Do they have a common factor? They have x. If x is the factor, it means I undistribute that, and what do I have left? Well, if I took out an x from here, that would be leaving me with just 7x, so that when I remultiply it, it gives me 7x squared. And if I took out an x from here, I have to have a placeholder. I can't just say it's gone. This must be plus 1. So that when you redistribute it, x times 7x is 7x squared. X times 1 is x, and that's where we got the 7x squared plus x. That means that the length, which is the shorter one, is x, and the height, or the width, must be 7x plus 1. Those are the two dimensions. Now we're going to get into a little bit more complex factors. In this example, you are asked to find the common factor of this expression with this one. So for the sake of these types of questions, you've got to look at this as one term and this is another. Even though it's not really a term because you would have to distribute, let that addition sign separate those two parts. The definition of a common factor is a factor that both have in common. Well, when you look at these here, you notice that this blue expression and this red one both have x plus 2 in common. So when you factor out, you're going to factor out the x plus 2. And when you take out the x plus 2, you're left with 5 plus 3x, which in standard form must be written as 3x plus 5. So now you see that you have a binomial and a binomial. If you were to redistribute, what you're really saying is you're going to take x and multiply it by 3x, and then you're going to take the 2 and multiply it by the 3x. So you're really going to take the x plus 2 and multiply it by the 3x. And then you're going to do the same thing to the 5. X times the 5 and the plus 2 times the 5. So really it's x plus 2 times the 5. So the hard part for you is going to be to look at the binomial, which is inside of the parentheses, and recognize that this, if you have the same parentheses in both, that means that that whole entire parentheses is something that can be factored out of that full expression, leaving you with 5 plus 3x. So looking at this one, hopefully your eyes immediately go to the common b squared plus 1, which means that when you factor out b squared plus 1, you're left with negative 2b and then plus, not 0, remember there's an understood 1 here. So it's negative 2b plus 1. So that if you want to check your work, you're going to do b squared plus 1 multiplied by the entire negative 2b. So negative 2b times the entire b plus 1, b squared plus 1, and then 1 times the entire b squared plus 1, which just gives you b squared plus 1. What we're going to be doing starting in the next section is you're going to notice that once you factor out the GCF, these guys in here are potentially going to be able to be factored even further. But the very first step will always be to GCF it first. You're always going to GCF first. Okay, looking at this one. When I look at this, I notice that they do not have a common parentheses. These are not the same. So I can't factor out the parentheses. And 4 and 9 don't have a common factor besides 1. So I can't factor that out. So this is already simplified. It is already factored out. If I change the problem so that instead of 9 it was 16, then what you could have done is taken out a 4 from here, and you would have been left with just z times z squared minus 7, and then plus, and this, when you factor out the 4, you're dividing, so that would become plus, and then 4 times 2z squared plus 1. And then that's where we get the idea of creating bigger brackets instead of curves so that we know that that's the bigger one. I know this example that I just made up is probably going to be a little bit more confusing. Let me reassure you that was just me trying to get you into a little bit more high-level thinking. You are not going to have something like this yet where that is going to go into something you could take out. It will just build up upon that. The fourth type of example is when you have 4 terms. Whenever you have 4 terms, the very first thing you're going to do is factor by grouping. Basically what you're going to do is you're going to say, all right, you guys are one group and you guys are one group. And then you're going to GCF each parenthesis separately. Looking at 6h to the 4 minus 4h to the third, hopefully you recognize that both of them are divisible by 2 and that we have an h to the 3 in common. That leaves me with 3, because 2 times 3 is 6, h, because h to the 3 times h is h to the 4, minus 2 with no h's because I took out the h to the 3. That's the first one. Then I write that plus and I move to the second parentheses. What does 12h and negative 8 divide evenly by? Well, if you don't know, you can do the 2 times 2 times 3 and the 2 times 2 times 2, and you realize it's 2 times 2, which is 4. Or you just know that 12 and 8 are both divisible by 4. So 4 comes out. What's left? 12h divided by 4 is 3h. Check your work. That's going to give you the 12h that you are factoring out. And then negative 8 divided by 4 is negative 2, because that's going to give you negative 8 that you are factoring out. Now from here, you step back and look at the whole thing, and hopefully you will recognize that you have this parentheses, which is the same. Which means that when you go to factor, you need to factor out even more. You take out that 3h minus 2 that they have in common, that's the GCF, and if it helps you to cover it up, you're left with 2h cubed plus 4 in the other parentheses. Now, if you wanted to check your work, you would FOIL this and make sure that you got the same that we originally started with. So let me just show you how you can check your work. I'm checking my answer by taking the binomials that I have left, FOILing 6h to the 4 plus 12h minus 4h to the third minus 8, and then looking at the original one to see if it's the same, and in fact you will notice that it is. So I know that my factored binomials were factored correctly, and these are the factors of that fourth or quartic 4-term polynomial. So let's do this one. 4 terms means you got a group factor. Group factor. 5 and 15 are both divisible by 5. I have 4 y's, I have 3 y's. That means I could take 3 out. What am I left with? Well, I had 5y4, I'm left with a y. I had minus 15y to the third. That means this must have been just minus 3. And that's it. Next one. And that's it for that group. What do they have in common? A y. So plus, don't forget that plus, the y. What's left? Y minus 3, because y squared divided by y is y, and negative 3y divided by y is negative 3. To make it more straightforward, you redistribute just to make sure that that's what's correct. Y squared minus 3y. What do we have in common? More? That parentheses. I have y minus 3 in common, so I GCF it, I take it out, and I'm left with 5y cubed plus y. Now, at this point, you look at it and go, can I take out any more y's or numbers? Can I take anything else out? Well, looking at this here, hopefully you recognize that this 5y cubed and this y, they both still have a y that they could be taken out of. So if I rewrite the y minus 3, because it's already simplified, and then I look at this and I realize, well, this little thing can actually factor out a y and leave me with 5y squared plus 1. Now you're going to have 4 factors. 3 factors. 1, 2, 3. Because the y 5y3 plus y that I had left after I factored out up here could still be factored even further. There was still something that it could give to take out, which was that y. This is the factored form, the complete factor form. Okay, 4 terms again. Group factor. Step 1, what can I take out of both of these? 2x squared. What's left? I had 3 and I took 2 out. I'm left with 1. Minus 12 divided by 2 is 6. I had 2 x's and I took them all out, so none. Rewrite that plus so that you don't think it's a multiplication problem. What can I take out of 18 and negative 3x? Remember that. It should be in standard form. So that's the same thing as saying negative 3x plus 18. And when the first coefficient is negative, you're going to take out a negative. So 3 and 18 are divisible by 3, but it's negative, so I'm going to take out negative 3, and I'm left with x minus 6, because 18, if you divided negative 3 out, you're left with negative 6. Check your work. Negative 3x plus 6, or plus 18. Now I see that I have the same parentheses right here. I have x minus 6 at both places. That means I'm going to take out the x minus 6. That's going to be factored out of both. And you're left with 2x squared plus negative 3, which is just 2x squared minus 3. Now you have the complete factored form. Your job is to go ahead and do factoring. Please make sure you factor all the way. So that means that if you are left with a binomial or a trinomial that has something you can continue to factor out, you got to do it. And you always GCF it first. That's the first step to factoring. That's all we're doing in this section, but the next section is going to require that you understand that if they tell you to factor, the first thing you have to do is take out the GCF and then continue to factor. Make sure you upload this to Canvas and ask questions tomorrow if we have any questions.